Introduction to Statistics, Chapter 10, Hypothesis Tests Regarding a Parameter. This is Section 10.2, Hypothesis Tests for a Population Proportion. Recall that the best point estimate of P, the proportion of the population, with a certain characteristic is given by P hat equals x divided by n, where x is the number of individuals in the sample with the specific characteristic and n is the sample size. Requirements for running a hypothesis test for a population proportion. This is similar to what we did last chapter. The sample is a simple random sample. N times P times the quantity 1 minus P has to be greater than or equal to 10. The sampled values are independent of each other, which means the sample size is less than or equal to 5% of the population size. Those three requirements must be met to run a hypothesis test for a population proportion. When observed results are unlikely under the assumption that the null hypothesis is true, we say the result is statistically significant and we reject the null hypothesis. Hypothesis testing for a population proportion P. Classical approach. Step 1. Determine the null and alternate hypothesis. Okay, from earlier in chapter section 10.1, if it's a left-tailed test, the null hypothesis A sub naught is going to be P equals some value P naught. And H1 is going to be P is less than P naught. A right-tailed test, the null is still P equals P sub naught, but the alternate would be P is greater than P sub naught. Two-tailed test, the null would be the same, P equals P sub naught, but the alternate would be P is not equal to P sub naught. Okay, step 2, select a level of confidence alpha depending on the seriousness of the making a type 1 error. Most of the time, 1%, 5%, 10% are used. So alpha would be 0.01, 0.05, or 0.10 most of the time. You could use different ones. Step 3, compute the test statistic. Now, this has a formula. The formula is Z naught is equal to P hat minus P sub naught divided by the square root of P sub naught times 1 minus P sub naught divided by n. Okay, you would just plug values in, calculate it. Now, as we go on, we're going to use StatCrunch. StatCrunch will calculate this test statistic for you. Step 4, sketch a curve for the test. Okay, remember, if it's left-tailed, you're going to have the left tail shaded. Right-tailed, right tail shaded. Two-tailed, you're going to have both tails shaded. And then the shaded region is going to add up to alpha. So if it's a left tail, the shaded region is alpha. Right tailed, shaded region is alpha. Two-tailed, each tail would be alpha divided by 2. And then you would find your critical values for alpha. Step 5, compare the test statistic with the critical value to see if the test statistic is in the critical region. And then you would write a conclusion. So if I go back here to the previous slide, okay, looking at these, here's your critical value. Okay, if your test statistic would end up in the shaded region over here, then it would be reject. If it ends up over here, you would fail to reject. If it's a right-tailed test and the test statistic ends up here in the shaded region, you would reject. If it ends up over here, you would fail to reject. So what you have to do is take the test statistic and compare it to the critical value. So in this case, since we're on the right-tailed, if the test statistic is greater than the critical value, you reject. If it's less than the critical, you fail. On a left tail, if it's less than the critical, you would reject. If it's greater than the critical, you would fail to reject. Okay? And two-tailed, of course, wherever it's less than the negative critical value, you'd reject. If it's greater than the positive critical value, you would reject. Okay, then we're going to write a conclusion. Now, the conclusions are very similar, just changing the words in them. So first off, this is your basic conclusion. There blank enough evidence in the data at the blank level of significance suggests that blankety blank. Okay? So this would be there is or is not. Okay? If you reject the null hypothesis, if you reject, you use the word is. If you fail to reject, you use is not. So keep that in mind. Reject is, fail to reject is not. And what level? This is your alpha. Okay, that could be 1%, 5%, 10%, or some other percent level of significance to suggest that. Now, the end of it comes from the problem. Okay, you would take this right from the problem, and we will do some examples here so you see what I mean from the problem. Okay, now if you're doing a hypothesis testing using the p-value approach, step 1 would stay the same. Left-tailed, right-tailed, two-tailed test. So step 1 is the same. Step 2 is the same. Determine your level of confidence. Now, step 3 is the same. Compute the statistic. Okay. Now, step 4, you would find the p-value for the test statistic using table or StatCrunch. We did this in previous chapters. So you have a test statistic, you have a z-value. You can use the table or you can use StatCrunch to find the probability according to the alternate hypothesis. Now, so if it's a left-tailed test, the p-value is the probability z is less than z naught. If it's a right-tailed test, you're looking for the probability it's greater than z naught. Two-tailed test, you would take 2 times the probability z is greater than the absolute value of z naught. Now, step 5, compare the test statistic p-value with alpha. This is important. This is something you're going to want to remember. If p-value is less than alpha, reject the null hypothesis. Remember, p-value less than alpha, reject the null hypothesis. If p-value is greater than alpha, fail to reject the null hypothesis. So you have 2 cases. P-value is less than alpha, p-value is greater than alpha. Know when you reject, know when you fail to reject. And step 6 is write a conclusion, which is the same as what we did before. They're blank, which is not, the level of significance, and then from the problem. That's the p-value approach. The only difference is we're using the p-value and comparing it to alpha instead of taking the test statistic and comparing it to the critical value. All right, using StatCrunch. This is going to be similar to what we did last chapter. Step 1, you're going to open up StatCrunch. Step 2, you're going to click Stat on the top menu, highlight Proportion Stats, highlight one sample, click with Summary or with Data. Depends upon whether you have the information or you have a list of data. Enter a value for the number of successes. This is X. Enter a value for the number of observations. This would be N. Click circle beside hypothesis test for P. This last chapter we did the confidence interval. Now we're going to do the hypothesis test. Enter the P naught value. Choose correct inequality sign. Less than if it's a left-tailed test. Greater than if it's a right-tailed test. Not equal to if it's a two-tailed test. And click compute. Now let's look at some examples. Okay, I cut this out of your ebook so it's a little blurry. Lipitor. The drug Lipitor is meant to reduce the cholesterol and LDL cholesterol. In clinical trials, 19 out of 863 patients taking 10 milligrams of Lipitor daily complained of flu-like symptoms. Suppose that it is known that 1.9% of patients taking competing drugs complain of flu-like symptoms. Is there evidence to conclude that more than 1.9% of Lipitor users experience flu-like symptoms as a side effect at the alpha equals 0.01 level of significance? Okay, so when you have your problem, the first thing you want to do is figure out what X is, which is 19. That's the number of successes. Then you need to know N, which is the total number, which was 863. Okay, Then we want to know our P naught. What are we comparing this to? We're comparing it to 1.9%. Well, you have to write 1.9% as a decimal, so it's 0.019. And then you need to know the level of significance. In this case, it's 1%, 0.01. Okay, that information you need to get from the problem. Next, you need to understand what you're testing. So we need the null hypothesis and alternate hypothesis. So the null hypothesis would be you let P equal the 1.9% or P equals 0.019. The alternate is, what are we trying to prove here? That more than 1.9%. More than means greater than. So we're trying to prove that P is greater than 0.019. So this information is needed before you use StatCrunch. Okay. Then when you go to StatCrunch, you would open up one sample proportion summary. You would put the 19 in for the number of successes, 863 for the observations. You would check hypothesis test for P. You would put the P naught value in here, 0.019, and it automatically propagates down to here. And then you choose the correct inequality, which was from our alternate hypothesis, greater than. So we enter the number of successes, sample size, click hypothesis, enter your P naught that you're checking against, choose your inequality. Now click compute, and you would get this. Now, what does this give me? Well, this gives me P hat. The sample proportion is your P hat. The Z-stat is your test statistic. Remember, I told you StatCrunch would find the test statistic for you. And of course, your p-value is here on the end. Okay, so when you use StatCrunch, it gives you the best point estimate, p hat, it gives you the test statistic, and it gives you the p-value. Now, since p-value is greater than alpha, the p-value in this case was 0.2582. That's greater than 0.01, which was alpha. Since it's greater than, we fail to reject H naught. Okay. Now, what does this mean? Since you failed, there is not enough evidence in the data at the alpha was 1% level of significance to suggest that. Now, from the problem, what were we trying to check? We were trying to check more than 1.9% of Lipitor users experience flu-like symptoms as a side effect. If you went to the problem, this is taken right from the problem. This is what you were trying to test. Okay, let me stop this a second and actually go to StatCrunch for this problem. So it's 19,863. Let's see. So if I go to StatCrunch, I would click on Stat, go down to Proportion Stats, one sample with summary. And if I recall, it was 19. I'm hoping it was 863. Not sure. Hypothesis test 0.019, and I wanted greater than. Click compute, and I think it looks like it's exactly what I had. Let's see. 2582. 2582. Yes, so I did have the right total, 863. Okay, and that's how you would go through StatCrunch. So now if I go back here to this problem, we'll go to another example. Now, taught enough math. In 1994, 52% of parents with children in high school felt it was a serious problem that high school students were not being taught enough math and science. A recent survey found that 256 of 800 parents with children in high school felt it was a serious problem that high school students were not being taught enough math and science. Do parents feel differently today than they did in 1994? Use the alpha equal to 0.05 level of significance. Okay, so once again, we have to go through the problem. Number of successes, 256. Sample size, 800. What are we testing against? We're testing against 52%, so P naught is 0.52. What's our level of significance? Alpha is 0.05. Now, what's our null hypothesis? Our null hypothesis is that P equals 52% or 0.52. What's our alternate? Our alternate is here, do parents feel differently? The key word is differently. So that would be not equals. So differently means not equal. So P would not equal 0.52 would be your alternate. Now if we go to StatCrunch, you would put 256 in for the number of successes, 800 for the number of observations or sample size. Click up. Click hypothesis test. Enter 0.52 for the p-value. It propagates down here. Choose the correct inequality, not equals. Now click compute, and here's your information. So in this case, sample proportion would be p hat 0.32. The test statistic would be negative 11.32277. The p-value is less than 0.0001. So that's a very, very small p-value. So since p-value is less than alpha, because less than 0.0001 is definitely less than 0.05, you would reject the null hypothesis, reject H naught. Now, what does it mean to reject? It means there is enough evidence in the data at the 5% level of significance to suggest that parents feel differently about the amount of math and science being taught today than they did in 1994. So again, this is taken from the problem. All right, now let's go to and actually see it in StatCrunch. So if I end the show here, and it was 256, 800, 52%. So if I go to StatCrunch, stat, proportion, one sample with summary, 256 out of 800. Hypothesis test is already checked, 52%, 0.52, and you notice this down here changed. And I want to not equal because it's different. Click compute, and you notice I get the same thing here as what I showed you in the PowerPoint. Okay, but that's just running through StatCrunch for you. Now, if you have a two-tailed hypothesis test, you can use your confidence interval. If you had a confidence interval, you could use it to check a two-tailed hypothesis test. So when testing H naught, P equals P naught versus H sub 1, P not equal to P naught, if A times 1 minus alpha times 100% confidence interval contains P naught, do not reject the hypothesis. So if your confidence interval contains P naught, fail to reject. However, if the confidence interval does not contain P naught, conclude that P is not equal to P naught at the level of significance alpha. So let's look at this. If I ran a 95% confidence interval for the last problem, okay, you would get the lower limit of this, the upper limit here. What was our P naught value? Our P naught value was 0.52, 52%. Well, is 0.52 from here to here? No, it's outside of this interval. Since it's not in the interval, you reject H naught. Isn't that what we found before? So let me go back to our PowerPoint. To our StatCrunch. So if I go to StatCrunch, okay, this is what I found if I ran the hypothesis. Now if I go back to edit, instead of doing a hypothesis test, let me do a confidence interval. Now the key fact here is alpha was 0.05. That's 5%. So if alpha is 5%, then our level of confidence is 95%. So we want to find a 95% confidence interval. So I have that in there. Click compute, and you notice I get the same thing that I showed you in the PowerPoint. So the lower limit, upper limit. And P hat, the sample proportion, is the same. All right, and this brings us to the end of section 10.2.